Okay, so my PLTL leaders have mentioned that some students have had trouble knowing the difference between a dipole moment and a net dipole. And what I'll say is a dipole moment is present on one bond, and a net dipole is the whole molecule. So there's a distinction between polar bonds and polar molecules. So an example I'll give is if we have carbon and it's bonded to 4 hydrogens, or 3 hydrogens and a fluorine, versus if we have a carbon bonded to 4 fluorines. So if we look at these bonds, carbon and hydrogen, they're pretty closely evenly shared. Not exactly, but for the purposes of this class, we usually assume that they're evenly shared. But fluorine is a lot more electronegative. So fluorine is going to pull the electron density in this bond towards itself. So instead of these electrons being equally shared like that, the electrons actually end up being a lot closer to fluorine. So there's a partial positive left behind on the carbon. That's why we cross that arrow. So this looks like a plus right here. This looks like a plus. And then the arrow is pointing to where the electrons are going. So that's sort of a little bit of dipole moment. So there is a polar bond here. And then if we add up all the dipole moments, well, there's not much present in any of these. So overall, the molecule is also polar. So we also have a polar molecule. Now, so the dipole moment, that's on the net dipole. So the dipole moments we add up together to get the net dipole to find out if the overall molecule is polar. Now on this one, we have 4 fluorines that are all pulling in opposite directions. And so they're all pulling away from the center. And so they actually are all canceling each other out. So even though each of these, there's 4 polar bonds, actually the net dipole is nonpolar. Because if we add all these up, there's 2 pointing this way, 2 pointing this way, those are going to cancel each other out. So this molecule is not polar, even though it has polar bonds. So you'll have to determine if a molecule is polar based on the presence of polar or unpolar polar bonds and how they add up together. So that's kind of the difference between net dipole. That's the addition of all the individual dipoles to tell if the whole molecule is polar or not. And then the dipole moment is based on only one bond. This should say on one bond. And you're determining if the individual bonds are polar so that you can calculate the net dipole. So my PLTL leaders indicated that y'all were struggling with that, so hopefully that clears some things up. And let me know if there's any other things you want me to go over.